Grade 12. Molweni wakhona. I'm called Mr. Mnyaka, as you all know. Siqale organic chemistry in our first video. Now we are doing more problems kuyo. As kuba sine aim yokufikelela kuwe apha. Nonceda wena. Make sure intoba you make known your request to us so that you will know. As much as badizama ukukunika principle to make you understand the work esiyenzayo, I will not know equations of reason and answer. I will not know equations ezixakayo physics until wena undixelele, then I will answer those questions. So today, as we have started organic chemistry, I will just take some few questions 2017 December and lay some few emphasis on those principles. It won't be long, just a few times, then we'll move on. I wanted to do those questions so that begin laws ne principles. So what we will do today, we will do a revision to 2017 and I think it's 2018, I'm not sure, but two papers. So make sure you listen very attentive. I'm not answering questions, but I'm emphasizing the principle and the law. Thank you very much. So here in number 1, this is question 2. Here in number 1, you are given here ethyl butanoate. The first part here organic chemistry, naming, you have to name a functional group, all those molecules. Then the second part, the physical properties. The third part, the type of reactions. So, question paper. So the first part, naming, as you will see the question paper on the screen. Yes, so here we are given this molecule. This is what we have here. The first question is, write this compound. For this compound, write down homologous series. You all know that these are what? Esters. That is homologous series yapade. IUPAC name, you already see. We have got ethyl alpha connected to O, and from this C to this side, this is acid yako. So this is ethyl what? Butanoate. I believe it's not a problem. You see it already. IUPAC, write down the IUPAC name of the organic acid used in the preparation of this. In esters, this is what? This is alcohol, which is connected to this O. Then this one is what? Is acid. So the acid name, IUPAC name of this acid, as against the butanoic acid. That is what we see. Paula diagram. Number 4, structural formula of a straight chain functional isomer. So we know functional isomer is where we move from functional group to the other. So a functional isomer is a band. This is, it must have 6 carbon atoms and OH. So this is ester and acid. So this is a structural isomer. Then you'll put hydrogens, I believe you see. You know almost how to do those things. Put hydrogens. So this is the functional isomer of that molecule. Acidic way. Now let's move to 2.2. This was 2.1. 2.1. Yes. So 2.2, write the structural formula of 4-methyl pentanol. So we know here we've got a ketone and a 5 carbon atom. Where is the double bond? It's in the second carbon. which is here. And where is methyl? It's in the 4th carbon. So this is the structural formula for that one. So you 4-methyl pentan 2-on. So this is pentanol, which is homologous series here too. Then methyl is in the 4th carbon. So that is what is requested in that question. This is 2.2. 2.3. Consider the structural formula. You are given the structural formula. Now, for this compound, write down the general formula of the homologous series to which this belongs. When we look at that, we see triple bond. So this is alkyne. That is homologous series. These are alkynes. Take your marks. Oh, this is 2.3.1, 2.3.2. The IUPAC name of this. Okay, so go name a compound yako. You always start from the carbon which is closest to the functional group. So in this case, it triple bond here to it between 4th carbon and 3rd carbon. So this is 3. So apa, so triple bond between 3rd and 4th. Sipine sibena don foot, sibene ethyl, which is in the 4th, which is in the 5th carbon. Sibene methyl is in. So apa, sizabana ban, sizaba. So sabana 5, ethyl, ban foot, 2.4. 2.4 dimethyl hept 3I. This is what you will have. So target 13 marks wako pa 13 marks wako omnikwayo lowa ozikele. Then sibuye CP question 3 of that question. I believe they understand apa kwenzeka ntoni. Yilo yethu leyo. Elo hlobo. I just wanted to do quick questions and answers to this so that you see how to answer these questions and to lay some hidden mysteries here. So the question 3 will do. This is the question of what? This is the question of physical properties. This is question 3. These are questions of physical properties. You are given that diagram, those 4 graphs. If you look at this one, we are given vapor pressure versus temperature. If you analyze that graph, in that graph we have atmospheric pressure, which is 760. Then the atmospheric pressure sinandon up sina straight chain. So that means the graph ibonakala alkanes. Is straight chains must alkanes as ibonakala alkanes up. Yes, alkanes gas yes, but corn alcohols because long as saturated molecules as corn alcohols, corn esters, as long as started from alkanes because long as a single bond in between HC molecule. There's many functional groups as different. So our person is straight chain. So we'll here. Baba funa ntona bantu. Now number 1, give a reason why alkanes are saturated. It's simple. We all know single bond. They have single bond between HC atoms. You will writing along well. You know almost. So I'm not writing answers for you. I'm giving you the principle. Determine vapor pressure. Vapor pressure. So the pressure is vapor. You see, the pressure is vapor. So it land. This is the pressure. This is the pressure exerted by vapor in equilibrium with its liquid. In equilibrium with its liquid. I know you know definitions in a closed system. So these are just definitions which I believe you know. You all have textbooks, so it's not a problem. Let's go to number 3, where we analyze now. I love this question in analysis because it's where we exercise what we say we know. Illos exercise apart. Looking at the diagram, use this information on the above graph to answer the following question. What is the effect of an increase in temperature on the vapor pressure? When you look at that, when increase temperature, if vapor pressure decreases. So you will select or write decreases there. 3.3.2. Which compound has a boiling point of approximately 68 degrees? A boiling point, we all know, is a point where vapor pressure equals to what? Atmospheric pressure. So at 68 degrees, P and a boiling point, A close to that. When you look, it's graph Q. So these definitions, you must know them and apply them. So let's see as zero, finesse was going born graphical. So that is what you have here. Then 2.3, which compound has the longest chain length? Fully explain your answer. Here if you compound, question is equals 4, and the chain length is high. We know almost that if the chain length increases, then we will have high energy. So the one that have energy high is the one that has what? It's the one that has a chain length. So here is number Q. It's number S here. Now let's explain this. So here you are given temperature. So here, at a low temperature, at a high temperature, vapor pressure is very low. It's very low. We have low vapor pressure according to the graph. So we are taking that information C place Z. So if a temperature is high and if vapor pressure is low, it will end up we have highest melting point and boiling point. We know most vapor pressure is very low. So if a boiling point and a melting point is high, it will end up high energy is required to break the bond, to break existing bonds. Then you take your marks. So hapa unakuwa the information yako, especially this part. Unakuwa the information yako ndio yaziyo we place now to a question. Ovumbozo wako, umbozo wewe ba usingaphi ufuna ndoni. Let's go also to this one, the last one. Now we are in number 3.4. You don't have to stress here, you just have to take your marks. These are your marks. You have to know what is happening, and if you know the principle, you don't think, you just apply what you know. In number P, we are told compound P has 5 carbon atoms. We know it has 5 carbon atoms. Let's write that down. Now that is carbon atoms E5. When draw a structural formula. Number P most is the one that has high vapor pressure. So that means the alkane layer. Draw a structural formula of a chain isomer of P. So we have a chain isomer here. So the structural formula now is a chain isomer. This is pentane. according to what we see. So pentane can break into two forms. It can break into, then we have one here, can break into this form. Okay, it break into this form. It break into this form. Indlela breaka ngayo le. Ufumane phaya intoni